All right, so do you remember how to identify a quadratic? What in it, in the equation, lets you know that it's a quadratic? What are you looking for? Yeah.
X is raised to the second power.
Exactly. You have x raised to the second power, and there's no higher degree. I don't have an x squared and then an x to the third, for example. So if I look here at these examples, I have x squareds. I have x's also, but the second is my highest power, okay? So these are all examples of quadratics, and you have 4 ways that you learn to solve them. Do you remember? So let me just jot that down. 4 ways to solve quadratics. Okay, you got one?
Completing the square.
Yes, you can complete the square. Do you remember when that's a good idea? Right, you want to not be able to factor, so there's one of my other ways, right? Factor. So I want to use this. Let me grab another color. Oh, let's do this fuchsia color. So can't factor, and when else? What are you looking for that makes an equation a good candidate to complete the square? Do you remember? You want to do this when it had something to do with b. Remember, well, let's maybe we have to go a step back. Remember, quadratics look like this: ax squared plus bx plus c. Right. So when I'm referring to a, b, and c, it's just the coefficients. What was that?
Piece of fraction.
If b is a fraction, it's annoying. Yep. Right. If b is even, it makes your life so much easier. You still can complete the square, but then you're going to have to deal with fractions, and who wants that? Nobody. So if b is even, it's a good idea. B is even makes it easier. The other thing about completing the square that's important to remember is that a has to be 1. So if it's not 1, then you have to divide everything by a, and that can make things turn real nasty. So, but sometimes it works out. So just remember, I'll just say, remember a must be 1. Okay, so there's that. Melissa, right, mentioned factoring. So that is another way to solve a quadratic. That's one of your easier ways. The problem is, as we know, not every quadratic can be factored. But if it can, we're going to go with it. How else? Go ahead.
Quadratic formula.
Yes, the quad formula. Can you guys do me a favor and write the quadratic formula? Write it. Do you remember it? If you remember it now, especially if you haven't taken math, if you didn't just take math last semester and you still remember it, that's a pretty good sign that it's stuck in that brain forever. So please double check that you wrote exactly what I'm writing. X equals negative b plus minus big old square root b squared minus 4ac. All of that needs to be under that square root, and then the whole thing is divided by 2a. So double check that you wrote it like I did. That fraction bar, make sure that it's over the whole thing. A lot of times kids mess up and they only put this over the 2a. That's not it. You have to have the whole thing over 2a. All right. So when should I be using quad formula? Yes, that's really, honestly, should be your last option. The easiest one, though, we haven't mentioned yet. Oh, you can graph it, yeah. So I guess you really have 5. Yeah, square rooting. The problem with square rooting is, again, that's another one that you can't do all the time. It has to be a certain circumstance in order for you to solve by square rooting. What does that circumstance have to be? Has to be what? No, you use a radical to get there to your answer. You can't have a linear term. So if you look up here, here's my quadratic term, here's my linear term, and here's my constant. So the linear term is the part that has just the x to the first power, so I can't have that term. In other words, b has to be 0. So I can't have an x. So if I'm looking at the 3 examples that we have here, none of these could I solve by square rooting. So I'll give you one that you can. So square rooting, let's just note, cannot have a linear term. Okay, so that might look something like, oh, I don't know, about 6x squared minus 3 equals 18. Something like that. There is no linear term there, so I could solve this one by square rooting. Do you remember? Kind of? Why don't we go ahead? Yeah, you're just going to get your x by itself. So let's add the 3 over 6x squared equals 21. Divided by 6. Of course, I didn't pick nice numbers. I can reduce by 3, though. 7 halves. And then what would I have to do? Now you need to square root both sides. And when you are solving an equation and you take a square root, what do you have to remember? Yeah. Yes, positive and negative roots. You need both of them. So, and then what's the other thing you have to remember about this? Because you can't leave your answer like that. Yeah, you have to rationalize that denominator. Do you remember how? Yes, so in this case, I'm going to multiply by, yeah, so remember that you can split up a square root in a fraction. It just turns into square root of 7 over square root of 2, right? You can split them up. So then you're just going to multiply by square root of 2 over square root of 2. And some of you might just be able to do this in your head. That's fine. Plus minus, so that's going to be square root of 14 over 2. Yep. Do you remember, just while I'm thinking of it real quick, is that a final answer? That is, but this isn't. Let's just pretend that your answer had been, oh, I don't know, that. That's not a final answer, but that is. Why? What's up with this? Yes, you remember all that business about simplifying square roots? If it has a perfect square factor, you can simplify it, right? Just like you simplify a fraction, like you would never leave 4/6. You would always reduce it down to be 2/3. Same thing, because they have a common factor. So here, anything you have under a root, if it has a factor that is a perfect square, so remember your perfect squares, 4, 9, 16, 25, all those, right? Since that can be split up, so I'll just do it down here. Square root of 18 can be split into the square root of 9 times the square root of 2. So it's really 3 root 2. Right? So they are the same thing, the square root of 18 and 3 times the square root of 2. If you pop them in a calculator, they're going to spit out the exact same thing. Okay? But same thing with 4, 6, and 2/3. They are the same thing. If you do 4 divided by 6 and 2 divided by 3, same. So same idea here. So just like we don't leave fractions unreduced, we don't leave radicals unsimplified. All right? So just keep that in your mind if those pop up. All right, so those, oh, and we should throw graphing on there. Graphing is nice when it's nice. And if it's not nice, the problem with graphing is what happens when the solution is like 1.47 and you're doing it by hand, like you're never going to be able to find that. So if it happens to be on nice points, yeah, graphing totally works. Or if I have a graphing calculator, and it can do it all for me. So, do you guys remember how to do each of these? Do you remember how to complete the square? No? So, we just did square rooting. Is that okay? Everybody's good with square rooting? Okay, let's go to the next easiest one, which is factoring. Okay, so I'm going to do the example that's on your note sheet there. So let's do factoring examples. So the example that's on there is x squared minus 7x equals negative 12. All right. I can't solve this by square rooting because I have b is not 0. I have that linear term. Okay, so the next thing I should try is factoring. But you need to remember how to factor. Do you? What do you have to do first? Yes, all the terms have to be on one side. You might also call this setting it equal to 0. Whatever you say, you need to do this, right? Move that 12 over. X squared minus 7x plus 12. Okay, so now you're here. Take a minute and see if you remember how to now factor this. Raise your hand if you have this factored. Okay, so some of us have it, some of us need a refresher. Here's the nice thing. When A is 1, I have a little rhyme. Okay, ready? When A is 1, you're almost done. Find factors of C that add up to B. So I'm looking for factors of 12 that add up to be a negative 7. So first of all, how could factors of a positive number add up to be a negative number? What must be true about those two factors? They're both going to be negative. Because essentially, remember what factors are. They're just two numbers that you multiply together to get a bigger number. So in order for two numbers to get multiplied together and spit out a positive number, they either both have to be positive or they both have to be negative. So I know that in this case, they both have to be negative because they're adding up to be a negative 7. So I know I'm looking for two negative numbers that multiply to be positive 12 but add to be negative 7. Well, 12 doesn't have that many factors, so hopefully we got there pretty quickly. Whatever those numbers are, remember you just put x in the first spots, and then what are those two factors that get me to negative 7? Negative 3 and negative 4. It doesn't even matter the order you put them in. You could have put the negative 4 there and the negative 3 there. It doesn't matter. Does that ring a bell? You remember? And then you can always, if you're not great at factoring, remember you could FOIL this back together and see if it really does equal this. If you were, because remember when A is not 1, now it's not so fun. Because there's a whole bunch of other, I don't have a good rhyme for that, but that's about it. But, so we'll do that in a minute, because A is not always going to be 1 for us. So anyway, we're not done yet though, because now we need to solve this. So I'm close. What do you do once you have the factors? You set each factor equal to 0. So I know you're probably looking at this and you know the answer is positive 3 and positive 4, but I want you to understand why you change the signs. It's because, look at the equation, right? It's saying this thing times this thing equals 0. Isn't anything times 0, 0? Yeah, so it doesn't, if this term right here turns into a 0, it doesn't matter what this one is. Because if that's 0, the whole answer is 0, right? So if I figure out what makes this turn into a 0, that means I have one of my answers. And then the same thing applies with this. If I figure out what makes this term turn into a 0, then the whole equation works. So that's why we take whatever is in there, we set them equal to 0. One of my answers will be 3, and the other one will be positive 4. So when you get your answers, if you have more than one answer for a variable, usually we put it in those funny brackets. That is not an ordered pair. That's not, you don't use smooth parentheses. That's a big no-no. Because smooth parentheses would indicate the point on the coordinate plane 3, 4, and that's not what you mean at all. What are these numbers really? What do these numbers represent? And so where is that if you were to look at the graph, for example?
Intercepts.
It's the x-intercepts, exactly. If you graph a quadratic, what shape is it? They're parabolas. So this particular parabola, if you graph it, what we just found out is that it's going to cross the x-axis at +3 and +4. So it's going to do something like this, right? That's what you're finding when you're solving a quadratic. You're finding where did that parabola cross the x-axis. So while we're talking about it, how many times can it cross the x-axis? It can obviously cross twice. It just did there. Does it have to cross twice? No. What else can it do? Go ahead.
Vertex could be on the x-axis.
Oh, yes. What if the parabola just came and did this? Just went boop. You would only have one solution there. So that absolutely can happen. And what actually usually happens with that, you'll still get two answers like this, but it'll just be the same number. So it'll just come out as 3 and 3. Something like that. And that's one other scenario. So it can cross twice. It can cross once. Can it do anything else? If you have a U shape. Yeah.
Just not.
Right. It doesn't even have to cross the x-axis at all. It could be up here. Right? These ends are going to keep going up forever. They're not going to come back down. So this would have no real solutions, but it does have two imaginary solutions, which you probably found in Algebra 2 at some point. Remember dealing with I? Oh, yes, I. So there's basically your three scenarios for quadratics, parabolas. It's either going to cross twice and you'll have two numbers, once, or not at all. Do you remember how to tell how many solutions it's going to have before you solve it? Yeah.
The x is basically the x squared. And the quadratic.
So the exponent will tell you how many solutions there are, but it won't tell you if it's two different ones, two of the same, or two imaginary. But you're right. So if I had a cubic equation, I would know I'd have 3 solutions. If I had something that was quartic or raised to the 4th, I'd have 4 solutions. But if I have a quadratic, there's a test that you can do to see which of these 3 it's going to come out as. Yes.
What's inside the root of b squared minus?
Yes. If you go back to the quadratic formula, that little thing right there, the b squared minus 4ac, it has its own special name. Everybody remember what that thing's called? Just b squared minus 4ac? Yes, discriminant. B squared minus 4ac is the discriminant. So the test is basically you do b squared minus 4ac and you're going to get out some number. If that number is positive, it means that you have 2 real solutions. So it's going to cross that x-axis 2 times, 2 different locations. If it comes out to be 0, that's how you get one solution. You're going to get the same answer twice. So the one real solution, so your vertex is on the x-axis. And then if it's negative, that's when you have no real solutions. Your solutions are going to be 2 imaginary ones. Okay, so I actually always like to solve, if I'm going to solve a quadratic by doing the quadratic formula, I do the discriminant first. Just so then I know, I would know right away if there's no solution, if I get a negative number for that discriminant. So, and it doesn't take me any more time because you have to do the b squared minus 4ac anyway. But It's helpful just to know what I'm walking into. Okay, so we did one factoring example. Let's do the next one on here. Oh, wait, no, I don't want to do that one. I want to do, I want to make one up because not all of those on that sheet are factorable. So give me 1 second, don't look. I'm wondering how you guys are factoring when A is not 1. Oops, minus 15. Okay, let's try solving this and see what you remember. 2x squared minus 7x minus 15 equals 0. Do you remember? Try and factor this. Now, here's where I think a lot of us are going to vary, because people are going to solve this different ways. They're going to factor it different ways. And I don't know which way you learned, or if you do it multiple different ways. I don't know. I don't know how you all do this. Why doesn't, can someone, did anybody get it? Okay, tell me what you did. Can you walk me through it?
Do you want X or?
I want to know, what was your very next step after you wrote this down?
So I did 2x in one parenthesis and then x in the other.
Okay.
And then I found factors of 15, so I did 5 and 3. And I put 5 and 1 just x. And then I did 2x times 5. I just checked it. I just did 2x times 5, which is 10x. And then the negative 3, which would be negative 7. If you did minus 5 and plus.
Okay, so I think what she was describing, I would call that guess and check, that method. Which is very handy, especially if your first and last don't have a ton of factors. Guess and check can be really nice. Did anybody do something different? Really? Everybody did some form of guess and check? Oh. Nobody did A times C, and then you like rewrote it and cut it in half? No? Did anybody do 2 times negative 15, and then you just drop the 2 for a second, and then you divide it back in later? No? Oh my gosh. Okay, well, I'm going to show you just some other ways if you wanted. I mean, if you have a way that works for you, go with it. But I just want you to know that there are other things that you can do. So, one other way to factor, this is probably my favorite. It doesn't really have a name. So, the first thing you do is you multiply A times C, and then you just drop it off. So, you do x squared minus 7x minus 30 equals 0. Okay? So, now for a minute, I just ignore the 2. I multiplied it over there, so ignore it. And then you're just going to factor this like you normally would. So factors, right now A is 1. I'm almost done. Find factors of C that have to be B. So I get x minus 10 and an x plus 3. My only gripe with this method is that a lot of kids forget and they stop right here. And obviously that's wrong, because those are not factors of my original equation. Here's what you do, and it's so cool, this next step. Here I multiplied that 2 in. Now I have to divide it back out. So what you do is you take that second term and you divide each one by 2. Now, 10 divides by 2 evenly, so that just becomes x minus 5. This one doesn't, so that 2 right there, you sneak it around and you stick it in front of that x. So it becomes 2x plus 3. Look at that. Look. They're the same. Isn't that something? So that's a neat little sneaky way. I will say this only works. It makes sense though. With anything, if there was a common factor in my original quadratic, wouldn't you always factor that out to begin with first, no matter what way you're doing it? So you do want to make sure that none of these have a common factor that you could have taken out to begin with. Otherwise, it kind of breaks. Did any of you do something called, I call it making t's. It's basically guess and check, but you might write the factors there and the factors here. 1, 15, 3, 5. Does everybody do something like that? Okay. We're all doing guess and check, whether you, I don't know. It's easier for kids to remember making the t's. There's also factoring by grouping. So you could have done, it's similar to, no, it's kind of isn't. So if you're going to factor by grouping, you still multiply a times c together first. And so that gets me negative 30. And then I kind of go over here and I just start trying to find factors of negative 30 that add up to be that negative 7. So negative 10 and a positive 3, right? Once you have those two factors, you go back in and you rewrite the quadratic, but you replace that middle term with these two guys. Minus 10x and a plus 3x. And then bring down that minus 15. Anybody do anything like that? And now that you have 4 terms here, you literally like divide it in half and then you factor each side. So this side I could take out a 2x. X minus 5. Here I could take out a 3. And then what's so cool about this is that those parentheses now match. That's one of your factors. So x minus 5 comes out, and then the other one is just whatever's out in front, 2x and a positive 3. So there's another way. Again, I don't care what you use as long as you have a way that works for you and you're good at it. And fast at it is helpful too. So if you're really good with your number sense, guess and check is probably going to be real quick for you. I don't know. Whatever you use. Does everybody have a way that works for them and they can do it? Okay. So, great. So that's factoring. Now, what happens if you can't factor it? Well, why don't we try the second one on this example sheet? This one here, the x squared plus 6x minus 2. X squared plus 6x minus 2 equals 0. All right, so I'm going to ask myself, can I solve this by square rooting? No, because I have a linear term. All right, so that's no good. I'm going to try and factor it. A is 1, so it shouldn't be that hard. Are there factors of negative 2 that have to be a positive 6? No, so that's out pretty quickly. Now, my next thing in my brain, I'm going to ask myself, okay, is this a good candidate for completing the square? This one is, because A is already 1, so I don't have to worry about that, and then B is even. If I have that scenario, completing the square is actually not that bad. I don't know, a lot of kids don't seem to like it, but in the right situation, it can be pretty nice. So, does anybody remember anything about completing the square? Or how you start? Yeah.
You add the 2 to the other side.
Correct. This is the one weird one that I actually don't want it to equal 0. I want to move C, that C term, to the other side. So let's start by adding that 2 over. And in doing this, I'm also going to leave this space here. So I want x squared plus 6x, and then I leave a little gap because I'm going to put some stuff there. And then, yeah, go ahead. What do you do now? Correct. I like finding, I call it the magic number. So I have to find the number that I'm going to add to both sides that makes this a perfect square trinomial, it's called. So it'd be a trinomial because it'll have 3 terms. And it's going to be a perfect square because when I factor this thing, instead of being like x plus 2 times x plus 7, whatever the 2 terms are, they're going to be exactly the same. Okay, well, it'd be crazy for us to just guess this value, but luckily there's a pattern. You want to take half of b and square that number. So half of 6 is 3, right? And then 3 squared is 9. So that tells you the magic number that you must add to both sides. That's another common mistake, is that oftentimes students forget to add it to this side. They just add it there. You can't do that, right? It's an equal sign. You got to add to both sides to maintain the balance between the two, right? Okay, now I was talking about that perfect square trinomial business. So this side's just 11. This side, though, this is what's so cool. If I factor this side, factors of 9 that add up to be 6 are just x plus 3 and x plus 3, right? So instead of writing it as 2 separate ones, you just write it as x plus 3 squared. And now I can square root both sides, exactly. So on the left, you just get that x plus 3, and on the right, 11, I can't simplify that radical, so I don't have to worry about that, but I do have to worry about plus minus. If you take a square root, you need to consider both roots. Okay, I'm almost done. I'm not quite done yet because I don't have x all by itself, so what do I do now? Yeah, just minus that 3 over. And then whenever you have numbers like this is how we write it. We're just going to take that negative 3 and you just shove it. You just shove it right in front there. So you get negative 3 plus minus that square root of 11. And that's it. So this thing is crossing the x-axis in 2 locations. One of them is at negative 3 plus root 11, whatever that number is. And the other one is at negative 3 minus root 11. So I certainly would not want to graph this one by hand because that would be a nightmare. But it's doable. Is that okay? Should I give you one to try? Okay. How about, I'm going to make one up. I won't make it too bad. All right, try that. I don't know if this is one that could be factored or not. I hope not. I didn't mean for it to be. Oh shoot, I think it is. Solve it by completing the square though. It'll just work out nice. But practice it with completing the square. Make sure you don't get too far without forgetting to do something. What has to be true before you can complete the square? Something about A. A has to be 1. So make sure that you are getting A to be 1 real quick. Did it come out nice? Good. If yours is not coming out nice, let's walk through this. It actually doesn't matter if you move c to the other side first and then divide everything by 2, or do it the other way around. It doesn't matter. Just make sure that you do both steps. So I'm actually going to do both at once. If I divide everybody by 2 and move that 18 over, you should have gotten x squared minus 10x, and then that would equal a negative 9 on that side. So do you have a line somewhere that looks like that at first? Okay, now what's my magic number in this case? 25. I want half of b, so that's negative 5, but if you square that, you get positive 25. Your magic number will always be positive, right? Because whether I square a positive number or a negative number, it comes out positive. So I should always be adding a number to both sides. In this case, it's 25. So over here, that's just, what, 16? And then here, factors of 25 that add to be negative 10, negative 5, and negative 5. So I read it like that. Square root both sides. So now I'm at square root of 16 is positive negative 4, right? Don't forget positive negative roots. Otherwise, you're only ever going to get one root when there might be 2. Who knows? So, positive negative roots. Hi. What? Oh, yeah, sure. So we'll add that 5. Shove it up there. Now, you're not going to leave an answer like this, because you could do that, right? In the last example, I can't do negative 3 plus the square root of 11 unless I'm going into decimal form. But here, I can do 5 plus 4. Yeah, so I get 9, and I can do 5 minus 4. I get that 1. So did everybody get 9 and 1 as your answers? All right, all right. Okay, so then the only type we have left to talk about is quad formula. So I'm thinking, yeah, does this last one, 10? Oh, I think you can factor that one. So let me just make one up that you can't factor, and that you would not want to do completing the square on. So you had like 4x squared minus x plus, oh, I don't know, 10, I don't know. If you had this quadratic, okay, so I can't solve by square rooting, okay, I would try to factor real quick. Factors of 40 that add up to be negative 1, I don't think there are any. So I'm not going to get anywhere with factoring. Now, completing the square. That would be very inconvenient here, because a is not 1, so I'd first have to divide everybody by 4, so now b is a negative 1/4. You could do it, because you can take half of a fraction and square it, but you're dealing with tons of fractions now. So I don't know, if you like fractions, go for it, but I would probably just go quad formula here. That's the other thing. You can solve any quadratic with completing the square. It doesn't have to be that b is even. It just makes your life so much easier. And a is 1. You can. So that's the nice thing about having the different ways to solve it. Factoring and completing the square, factoring and solving by square rooting, you can't always do those ones. But you can always do completing the square and quad formula. And they will solve anything. But they're cumbersome, right? You don't want to be solving every single quadratic by quad formula. If it could have been factored, right? It would have been so much faster. So anyway, let's go ahead and solve this one with the quad formula. So of course, if you don't know the quadratic formula, then it's not going to be much use to you, right? So please make sure that you do know that quad formula and you've got it committed to memory. Okay, so I'm just going to rewrite it so we have it right in front of us. Okay, and then remember, what's a in this quadratic? 4. What's b? Negative 1, and c is 10. If it helps you to just kind of jot that over on the side, go ahead. I don't care. Whatever works for you. Make sure that the whole thing is equal to 0 before you say what A, B, and C are. That's a common mistake. So for example, let me just show you real quick. If I had given you the same exact quadratic, but it looked like this, right? I can't tell you how many times kids will just think that C is -10. It's really not, is it? You have to move it over first, and then you can see, oh yeah, C is going to be a +10. Make sure it's set equal to 0 before you go popping in what A, B, and C are. Okay, so go ahead, try it. Stick in A, B, and C. You do it on your paper, and I'll do it up on here, and we'll see if we all end up in the same spot. Did you get to where I got at some point? All right, so be careful. Watch your signs. -1, you're squaring. That comes out to be a +1. I only have that one negative, so that's going to be a -160. So I'm here. How many times does this thing cross the x-axis? 0. It never does because I have a negative under a radical. So my discriminant was negative. It's never going to cross the x-axis. But do you remember how I deal with the negative under the radical? How do I? Yes, I got to pull out an I. You remember doing that? Now, 159 is not a perfect square itself, and I don't believe it has any perfect square factors. So 4 doesn't go in, 9 doesn't go in, 16 doesn't go in. So the only thing I can do is pull out that -1. So my final answer would look like this. 1 ± I root 159. And the whole thing is over 8. And there's my final answer. Looks like a 4. There we go. Is that ringing bells? Do you remember this? Okay. Awesome. So that's it. That's solving quadratic. So I want to, let me stop this video here.